Okay, so we have a fair coin that is tossed repeatedly until either heads comes up 3 times in a row or tails comes up 3 times in a row. And what is the probability that the coin will be tossed more than 10 times? So the question is obvious and clear, I guess, but it is a bit messy looking because, we want to get um, at most 3 coins of the same type in consecutive like tosses, right? So we cannot get 3 until we toss this like at least 10 times. So we want to get like 3 consecutive ones are right after maybe 10 tosses. So for that reason, so we can try kind of casework, but it is gonna take too much work, and we just don't want to do that. So for that reason, I'm going to try something else. Like, let's say we have some like consecutive terms, right? So I'm going to say consecutive, like tosses, coins, could be 1 or 2 result. What I mean by that, like you could have either consecutive terms are different, like H, T, T, H, or TH. Like you can just have like every next term is different from the previous one, which means consecutive terms are like just one type. Or you could have 2 terms that is following each other might be the same, which means H, H, T, T, H, like T, T, H, H, and something like that. So, but we cannot have 3 same types. We cannot have 3 H's, 3 T's, and stuff. So we cannot do that. We can have only 1 or 2. Okay, so but we don't know how many of those, like let's say we have like some of these are gonna be the same. Let's say we have 2 H's, but which ones, like how many of those 2 possible? So like we can kind of count that based on cases. So if I want to say the number of like 2's, okay, make sure the 2's is basically the number of 2 consecutive, like the coins that will be the same type, so which is like 2 H's or 2 T's and stuff like that. Okay, and the number of T, like the 2's is, let's call this is N. So but the N, like if you have 2 consecutive terms are the same type, you could have N at most 5, because you could have like 2 H's first and then 2 T's after, 2 H's next, 2 T's right after, all the way to the 10 tosses. You could have only 5 of these. So I will say the N could be at most 5, but at least 0. Okay, so the number of 2's is in between 0 to 5, and the number of 1's is gonna be, I'm gonna call this is M. The M has to be, like it could be 0 to 10, but instead of writing this way, maybe we should do a bit better, because the number of M's are actually dependent on the number of N's. So which is why the number of M, I can just say 10 minus 2 times N, because if you have only like N is equal to 1, which means there are 2 consecutive terms are the same type, then the other 8 will be different. Like what I mean by that, they are going to just follow each other, alternating, right? So that's something we can say that. But how do we use this? Like, let's kind of come up with the first case. Let's say N, in our first case, if N is equal to 0, what is that supposed to tell us? And if N is 0, then M has to be 10. So meaning that you are going to have no consecutive 2 terms of those like tosses will be the same. So they are going to be all alternating. So if I start with, let's say H, the next one should be T, and the next one is H, and then T, H, T, H, T, H. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then T. So like, since we want to get the any like the next, like every next term is going to be different from the previous like term in terms of the headness and like tailness, right? So we just want to have this way, or we can start with t's and then we can end up with h's, which is going to be only two ways. But instead of doing this like two right now, I'm going to just count this one, and then at the end, when you swap h and t's, which can be done in every possible cases, we are going to double that at the end, okay? But instead of writing this, we can just say this is only one way, that's okay, but we want to make it kind of a bit nicer ways to kind of make a reasoning to write in a total number of ways to achieve this, okay? So like if you have like n2s and m1s, just kind of think about this way. So I have 1, 2, some number of n's, which is, we know this is the n of these, and then we have 1 and some number of the ones, which is m. So the number of ways to arrange these numbers, if you are remembering the permutation stuff, so since we have some repeating numbers, which is n of these 2's and m of these 1's, if they were all different, so the number of ways to do this was like n plus 1 factorial. But when there are some repeating stuff, we were just dividing by this n factorial by n factorial. So I can just say factorial divided by n factorial times n factorial. But I just don't like doing this because there is a nice combination approach as well. So we may say the number of ways to arrange these guys is just whenever you choose the number of like the places for those 2's, which is n of these 2's, then the other ones are going to be determined anyway, or the other way around. So if you determine the places for ones, then the place of 2's will be determined. So number of ways to do this, basically n plus m choose n. So we can just do it this way instead. Or you can say n plus m choose m, which is going to be the same thing in terms of counting. So, but how this is going to be kind of confirming our first number that we start with. Like in this case, if I want to choose n equals 0, which is right there, so that should be 0 plus 10, and then choose 0, right? And then we know this was only one way to do this. So that 10 choose 0, which is also 1, which is actually confirming our first approach. And if I choose n equals 1, and m equals gonna be like 8, right? Because that's gonna be 10 minus 2 times 1. And in this case, you can list those, but I think we don't really need to list anymore. So the meaning of this, just to remember, the n is 1, which means there will be only 2 like tosses that will be same type, so HH or TTs, and every other one should be like alternating. So let's see one example of doing this, okay? So if I have H and H as the first 2, and then the next one should be T, and then next is H, and then T, and H, T, H, T. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this is 10, I guess. So we cannot really split these guys because that's the point. And the all other ones has to be alternating each other. So we can just kind of try our best to organize these as well. And to see how many ways can we do this one with this restriction. Only thing we can do, since we cannot really swap these T's and H's, we can just change the place of the 2 H's. So we can move this like one places to the next, and then or next, or next, or next. Since we have like only option that we can play with that is just moving the position of the H's, and that will determine how many ways can we do that, which you can just count it easily. And I guess that's going to be 9 times. But we want to use our general approach, which is going to make a nice relation at the end. So then n is 1, and then m is 8, and then choose 1, right? So that will be 9 choose 1, which is just 9. Okay, so I hope you see what's going on now. So then if I want to continue this next as 2, m will be 6. So you will get 2 plus 6, choose, I guess we can choose 2 or choose 6, which doesn't make any difference. I'll go with like choose 2. Okay. And that will be 8 choose 2. And that's going to be 28. And then if I choose n equals 3 and m equals going to be like 4 based on the 10 minus 2n, right? So that should be n plus m. Actually, I should have chosen maybe this is like 6, but it doesn't matter. So I'm going to just keep it as 2. So since I want to use this n, so I just want to use like this guy. So if you choose m, so that's also okay. So if I choose n equals 3, so that should be 3 plus 4, choose 3, and that's 7, choose 3. And 765 divided by 3 factorial, that will be 35. And then if I choose n equals 4, that means 2n will be 8, so the m has to be 2. So that will be 4 plus 2, choose 4, which is 6, choose 4. And that's the same as 6 choose 2, which is 15. Okay, and the last case is n equals 5, m equals 0, which is also easy to list those cases. So the 5 plus 0 choose 0, which is gonna be just 1. Or actually this I can just go with since I changed the order, like n plus m choose n. So I did 5 choose, okay. And then that should be 5 plus 0, which is n and m, choose n, which is 5 actually. But like 5 choose 5 is also 1, so which doesn't matter. So if you add these guys, we have like 1, 10. And if you add these two, that's 50. So that's like 60. And then 88 and 89. So in total, we have 89 ways to achieve this. Just remember, at the beginning, I said we can just change those h's and t's. Instead of starting with h, we can start with t's, or instead of having these two h's, we can start with 2 t's and then just continue from there. So the number of ways to do this is 89. When you have the h's as our first step, but you can always swap these h's and t's. So which is why we have to double this number. And this is our desired outcome. And we want to get this more than 10 rows. So if you want to get more than 10 rows, every task you have 2 options, T or H. So which is why you have 2 to the 10 total outcome. Okay, for the 10 tasks. So that will give us 89. So if you divide, this is 1024 divided by 2, so you'll get 512. So I hope that was clear. So here's my challenge for you. If we kind of use this approach or any approach you like as a guide and see if we can get a general like expression for the same type of question. So if you have a fair coin toss until either heads or like tails comes up some number of times. In this case, we did say 3. So let's say this is n times. Okay. So let's say this is n times. And then even like to make it a bit more challenging. So we can say we are gonna toss more than m times where we have m is larger than n. So you can try this question as an extra challenge and see if you can make a general expression. And as soon as you have that, you can always test that expression or your formula with the concrete values, which is like we just have in this problem was 10 times with 3 consecutive terms. Maybe you can do this like 2 consecutive terms and maybe 5 times, and then 3 consecutive terms like 15 times, and kind of apply those different cases to test your expression. We can always test your expression with this problem itself, which means you can choose n is 3 and m is 10. and see if you are really getting 89 over 512. And if so, then your formula should be good looking. And good luck on that challenge.